What I notice a massive amount of people doing is consistently duplicating a lot of scenes and then putting them into their project like this, and it's slow and manual. So I invented a new way that uses tile maps to indicate where placements of these scenes will be, and there's code that will run through and duplicate all of these for you. So let's get started. So I am going to leave timestamps throughout this video so that you can just skip straight to the Tilemap Instancing part, but I will go through how to set up the scene and all of that stuff just for beginners. So I opened up Godot and I created a new project, and I'm specifying the project folder within all this. Hopefully you have most of this set up by now. If not, I would recommend watching more beginner-based tutorials. So now that I've got a scene created, I will create a new node 2D and call it world, the typical stuff. And I'm going to create a new folder for all of the assets, which I misspelled many times. And the assets folder just contains all of the sprites and pictures and, assets. And I'll leave a link in the description for a couple of these, but they're just basic blocks and circles, nothing too special. So I added a child node for a tile map, and then created a new tile map, threw in the assets, created a new single tile, and added the collision, and I'll add on the occlusion in a little bit, but I added on the collision and occlusion, which just basically say where the block is and where it should block out light. So occlusion isn't really necessary for this because I didn't add in anything light to this project, so that doesn't really matter. Don't worry about that. So I created just a little world, put some grass blocks on the top. Nothing too special, because all I really want out of this is to show the Tilemap instancing. So I created a source folder, which will just contain all of the code for the source, contrary to the assets folder. So create a new scene and call it player using a kinematic body 2D node, and add a child called sprite. Sprites are just nodes that will contain like an image so that you can represent your characters visually, and set it to 0.25 if you're using the things that I provided because they're kind of big. So I had another child node and call this collision shape 2D and give it a circle shape so that we can define this node's collision shape. And my sprite is just a little bit off center, so you can move that around if you want, but you don't have to. So here I add in a player script so that we can control the player, and I added in some variables for move speed and velocity. Velocity will represent where we want to move, and so then we also create a variable for jump height, which represents how high we want to jump, and then gravity, which will represent how much we're getting pulled down. So then I created the physics process function, which is called 60 times a second by standard. And so right off the bat here we have velocity.y plus equals gravity. So when we create a vector 2, it has two things. There's the x and the y, and so we're just going to always give it that gravity. And I defined the jump height, the gravity, and the move speed variables here. So I created a function here called getInput. This is so that we don't just throw everything into physics process. We're spreading things out a little bit, making it easier to look at. So I created an if input is action pressed, and then realized I haven't set the input maps yet. So we're going to make one called left, right, and jump. Input maps are nice because you can add multiple keys and just inputs to one input action. So for example, for the jump input, I've added the W and the space key. So I press the quotation mark to refresh the IntelliSense and type in the left. So if the input left is pressed, then velocity.x minus equals move speed. Either that or it's an equal sign I can't see. And I actually made it negative move speed because it's left. So, and then if input dot is action pressed right, velocity dot x equals positive move speed. And then I created one more for the jump input, but I made sure that it was is action just pressed, so you can't hold it down and the player will continue to keep jumping. And for that we wanted velocity.y equals negative jump height. Because the y in Godot is upside down, positive y is downwards, and negative y is upwards. So I went into the source code folder after struggling to find it for a little bit, and I added the player scene as a child of the world, and then I selected the world as the main scene, and then that's when I realized I forgot to call move and slide, which is a super helpful built-in Godot function that will move the character based on the parameters given to it. So in this case I used velocity because that's what we've been defining this whole time. So it'll move the character based on velocity. And this vector 2.up thing, I don't really know what that does. I don't think you need it. So there we go. We have a moving character, and through here I messed around with the variables a little bit to get him moving faster. And you can do the same if you want. But right, now he's moving a little bit faster. So eventually when you're done with that, you're going to want to create a new scene and with a kinematic body 2D and call it enemy. Give it a sprite and give it the enemy texture, and then set it lower if you're using my sprites, the usual. And then add a collision shape 2D to it, so it's got a collision defined. And like I said, it'll be just a little bit off if you're using mine. And then I saved this as in the source code folder. So I attached a script to the enemy, and I got rid of all this stuff. And here I defined a couple variables. At first I just tried putting in move speed, but then I realized I had to define it as a variable first. Silly me. So I gave move and speed not as much as the player, but it doesn't really matter. And then I made velocity, and IntelliSense gave me some weird suggestions at first. And then gravity, which didn't really matter because I assumed these characters wouldn't be falling that often, but just in case they do. And then in the physics process function, I wanted it so that they would just keep moving back and forth, and whenever they would hit a wall, they would turn the other way. So there I put velocity.y plus equals gravity, so that they're always falling, and then velocity equals move and slide velocity, you know, the usual stuff, vector2.up for whatever reason. So for this, I wasn't thinking straight, and I called move and collide, which needed an extra parameter, so I fixed it to move and slide. So here I wanted it, so if the character was colliding with the wall, it would multiply the move speed by -1, so it would turn around each time. And you can only call is on wall if you're calling move and slide. Otherwise, Godot won't know what you're talking about. And I made move speed negative so that the character would always start to the left at first. So then I added the enemy into the world. And then I realized it was not working because I forgot to make the velocity.x move by the move speed. I did everything else, but not the move speed. So don't forget about that. So something I had done earlier was I had made velocity equal to a new vector2 every frame. Do not do that. It's the block of code right underneath physics process. So then I also, at the input is action press jump, I also called and is on floor. This way you can't jump while you're in midair. But yeah, I was sitting here struggling for a little while, trying to figure out why I wasn't jumping. I eventually just removed that block of code that was causing a lot of problems. So here I extended the world a little bit. Did a little bit of landscaping. So now if we want to add a large amount of characters, we press Control D, Control D, Control D, whatever. I find this very slow and tedious, especially if we have lots of enemies that we want to instance, or whatever kind of scenes you're going to be using. So, and you know, then if you want to get rid of them, then you have to delete all of them, which I guess can be faster than deleting one at a time, but still, it's slow to move them around, and I just don't like doing all of that, so I invented a system using tile maps to indicate where you want all of these scenes to be positioned. So add a tile map node and call it enemy tile map, or whatever kind of scene that you're instancing. It took me a little while to spell enemy correctly. So create a new tile map and put that into there. Now it doesn't really matter how many blocks you use or whatever it looks. However it looks, just make it so that it's good enough to fit the cell. And then you can put a few of those there. And what we're going to do is when we press start, the enemies should spawn at those positions. So it'll attach some code to the world node and add some code. And we're creating a variable for enemy, which is just going to be preloaded as the enemy scene, and I struggled to have the IDE cooperate with me on this one, or IntelliSense, whatever. This was not going well, but I got it typed in. And in the ready function, I call a function that will create all of our enemy scenes. I call this function instance enemies, and then I create the function lower down here. So basically what we want to happen is we want an enemy scene instance in all three of these positions. And it's like instead of dragging in my code, we just want this tile map to indicate where all of these positions are. So we have a variable for all of the open cells on our enemy tile map. By calling the getOpenCells method. And it doesn't really matter if you use getOpenCells or getOpenCells by ID, because if you have multiple cells in one tile map, then yeah, you would probably want to use by ID. But if you just had a separate tile map like I did for the enemies, then you can just go get used cells. Now I created a for loop, which is a little bit complicated in my opinion, but it's for I in open cells. So I will represent one of the cells for each time it goes through the loop. Like I said, I find for loops very complicated, so I have a hard time explaining them. So a variable enemy instance is made so that we can instance the enemies a couple times. And now we are setting the enemy's position to wherever the current cell is in the for loop. Using the map to world function. So it's getting the position of I, which is one of the cells, whichever one the loop is on, and it converts it into the real world of Godot, and then we add some code for adding the child, and then we also want to add some code so that that tile map space that we were just on gets deleted. So what we do is we set the cell that we're on, which we use I.x and I.y to represent where it is, and then we want to set it to -1, which represents like blank space. 0 is the first tile in the tile set, 1 is the second tile in the tile set, -1 is just empty space. So if we start this up, you can see that enemies have been instanced wherever we placed those tiles at. Obviously they've moved around a little bit. So if you wanted to create a massive amount of enemies, then you could do something like this and start it. So that's always really fun to try out. Thank you for watching this tutorial. I hope you learned something. I haven't seen any tutorials for anything like this, so I also hope like this is brand new. And yeah, thank you for watching.